Let us solve the following linear inequality. So this is a linear inequation because it involves an inequality sign which is greater than or equals to, and linear because we have a variable x with the highest degree of only 1. Right, so let us begin. In the first step, what we'll do, we'll take the least common multiple one for 5 and 3, and that's 15. So we'll multiply both sides with 15. So that means we have 15 times 3 multiplied to x minus 2 divided by 5. That is greater than or equals to 15 times 5 multiplied to 2 minus x divided by 3. Now since 15 is a positive number, so we have to always be careful when we are multiplying with any numbers. Multiplication and division requires a little bit of carefulness on our part. So for 15 being positive, so the sign of the inequality is not going to change. Now we have 5 times 3, so we have 3, so 3 times 3 will be 9, so we have 9 times x minus 2. So this is greater than or equals to, so we have 3 times 5 is 15, and 5 times 5 will be 25, multiplied to 2 minus x. So let's now distribute 9 with x minus 2, so we have 9x minus 18, that this is greater than or equals to, distributing 25 with 2 minus x gives us 50 minus 25x. In the next step, we will transpose negative 25x from the right hand side to the left hand side. So we have 9x plus 25x minus 18. So this is greater than or equals to 50. So 9 plus 25 will be 34x. And we will transpose 18 from the left hand side to the right hand side. So that means we have 34x is greater than or equals to 68. Now we want to isolate the value of x. All we have to do is divide both sides of the inequality with 34. We want to get rid of the coefficient of x. So this will be 68 over 34. Again, we have to be careful when we're dividing with a number because division might flip the change if it is negative. In our case, we have a positive 34. So this is not going to change the sign of the inequality. So this 34 and 34 goes away. So we have x greater than or equals to 2. So this is going to be our solution to the given linear inequation. There is another graphical way of representing this solution. So we'll consider a number line. Here we'll consider the points 0 and 2. On the extreme left, we have negative infinity, and to the extreme right, we have positive infinity. We need to consider all the values of x which is greater than 2. So this will be all the values of x greater than 2 lying on this number line. And here 2 is included because we have a equality sign as well. So since it is included, so we will use a dot. So dot means 2 is also included in our solutions. So next way will be writing in an interval form, which is also referred to as the solution set. So here we have our solution going from 2 to infinity. You can always use the number line to quickly write an interval. So we have our solution starting from 2 and goes all the way up to positive infinity. And we know that positive infinity is excluded. That means it's unbounded. So we'll have to use an open interval. And 2 is included. So we'll need to use a closed interval. So this is the third way of representing our solution of the given linear inequality. So these are the 3 different ways.